Okay, so in this problem, we're going to go through a process for analyzing this data set, essentially. We're given the advertised horsepower ratings and expected gas mileage for several 2003 vehicles. So we're going to be making a comparison essentially between, or looking to see if there is a correlation between horsepower and gas mileage. Is there a relationship or not? So you could probably predict what the outcome will be. But we're going to base it on this data table and see what we have. So first thing to do, as far as viewing what's going on here, it says to create a scatter plot. A scatter plot's a good way to just get a nice visualization of what we're talking about as far as the data is concerned. So when you're making a scatter plot, you're going to need, I'm going to have to pause this because I need a calculator going. There we go. Okay, so we're going to feed this information into our stat list. And the way to get that is by pressing the stat button. And then we're going to edit. And here's a list for the information. Now, you've noticed I've already gone ahead and put these in so it would save time in the video. But you can order these however you'd like. Now, the default is to put, if we're talking about X and Y, to put the X values in L1 and then the Y values in L2. Now, in this case, it doesn't really truly matter because we're just going to test for whether the relationship is linear or not. And turns out it doesn't matter. If one's linear, it can always be expressed in terms of the other in linear fashion. So that in and of itself isn't a big deal, but what we need to pay attention to is how the multiple choice options are set up. If you notice, on the x-axis, they are putting the horsepower. So we want to make sure horsepower goes into what we would consider our x, and the default is L1 for x. So put all that there, and then the y column can go in for L2, and that's where the miles per gallon goes. So just make sure you put those values in, double check. Once that's in there, you can quit. And now we're going to go back to stat, and now we're just going to generate getting ahead of myself. First, we're just going to get the scatter plot. So one thing to do with the scatter plot is, whoa, I apologize. That was my email. It scared me. So one way to get, or what we need to do to get the scatter plot, I should say, is to turn it on. It's a separate feature in the calculator that needs to be turned on. So we're going to click the second and y equals, and then you hit enter. And we'll just turn these stat plots on. So just make sure they're on. Everything else isn't so important. This is where you can reorder your lists. Where the x's go, where do the y's go. As I said, the default is L1 for x, L2 for y. But you can technically reorder that. All right, so now that it's on, we can technically look at the graph now, but we should also set our viewing parameters, the window, so click window, the same as what they have in terms of the multiple choice options. So we can actually compare them. So if you notice, the x min, the smallest x value shown is 100. So when I go to x min, I'm going to type in 100. And when I look at along the x axis, the largest x value is 350. And then if we go down to that y min, smallest y value you see vertically is a 5. And then 35 is the highest value. Okay, so, and everything else is not such a big deal. The shade resolution is confusing me. I'm hoping I don't have a separate module loaded. Well, we'll see when I go to the graph. So anyways, now you should go for the graph. And yeah, perfect. So now if you have your viewing parameters set the same as the options here, you should just be able to pick the graph that looks exactly the same. So if you notice, this is definitely the one we're talking about. So that's B. That's why it's got the blue check. So we got the scatter plot. Now let's take a look at part B. Part B wants us to, you don't necessarily need to do this step actually at part B. I honestly would probably do step C next and then do B, but I'll do it in the order of, maybe you'll see after we get to C. But I'll just do it in the order and way it's presented. So what's meant by negative versus positive in terms of the direction, the form, and the strength of this particular plot? Well, we'll start off with the negative versus positive. If you notice, when it says negative or positive, it just means how is it trending. As one gets larger, does the other get larger? That would be a positive trend. So, if, in this case here, if this, as x gets larger, looks like generally speaking, so too does the miles per gallon. This one here looks a little bit more sporadic, but we could say that may have a positive trend. These two look like they have a negative trend. Right? They look like they're more so going down. So we definitely want a negative. So that rules out these two. Now, as far as whether or not that relationship is curved or straight, well, we could maybe argue that it's slightly curved. for one thing, it doesn't really curve back. We can say that much. So I would argue that it's more straight than anything else. But all they mean by straight is, does it loop around, or does it follow a straight line? And then the last thing is the strength. Now, if you notice, we only really have one option at this point. I guess that's why they're doing that, so you can kind of weigh the two. So we already said these were out. Now we're knocking this one out. But then as far as the association is concerned, association really says, like, how tightly is the data packed around, like, our, in theory, a line that would be able to go through these, right? Like, if I put a line through here versus here, we can say the data points are going to be a lot more tightly packed around this line than they are here. So the more packed they are around that line, the stronger the association. So that's why the answer is D. Now, all of that we just did with given a scatter plot. So we did it, what you could say, geometrically. However, there is a value, it's called the correlation coefficient, and it'll give us, the calculator can run a diagnostic for us, and it can give us a much better understanding in terms of all the information we just looked at for part B. So, there's a couple things we got to do. You know what? Let me just go ahead now and show you how to get it, and then we'll talk about how interpreting it. Now, it's actually a separate module. It needs to be loaded in. It's part of a module called diagnostics, which is not default on the stock settings of the calculator. So the way to load this module is to click second catalog. There might be another way to do it. This is the way I know how to do it. Catalog is how you get to basically every command that exists in the calculator. So if we go to catalog, we're looking for just go scroll down. Again, second 0 gets you the catalog. Scroll all the way down until it says diagnostics on. And then you want to hit enter, and then enter again. Looks like it didn't do anything, but it actually loaded up a additional feature within the statistics menu here, which in a sense it helps the calculator save memory to not have this loaded up initially, but we do actually want the diagnostics on. So turn those on. Now once that's on, we can go to stat, and then we can go to calculate, and we want to calculate a linear regression model for the data set. Right? We want to see if there is a linear relationship. Let's generate it, and then that diagnostic, that R value, that correlation coefficient, is going to tell us how linear it actually is. How strong is this relationship? So we'll hit 4, or you can go down to that fourth option. Again, X1, L1 are your defaults for our X list. L1 is X, L2 is Y, are your defaults. You don't need to store it in this case, but storing is an option. Way again to store it, you do vars, yvars, enter on function, enter on y1. That can be very useful if you need to evaluate it. Right? What that does is it puts it into y equals for you, so you don't have to retype it. But anyways, if we hit calculate, with the diagnostics on, it'll give you these R values. And we want the R itself, the correlation coefficient. And let me tell you how to interpret it. So all you got to do here, if I'm not mistaken, actually, is to just say what the R value is. So it's negative 0.88. But how to interpret it is, first of all, the sign, right? The sign tells you whether or not there is a positive or negative relationship. Now, because it's negative, we know there's a negative relationship with this data set, meaning there's a negative correlation between the variables, which means as one goes up, the other goes down, right? That's what we saw. And hopefully that's pretty intuitive, right? As the car gets more and more powerful, we're probably going to see the gas mileage that it gets starts to go down. So that's indicated by the negative. If it was positive, it would mean it has a positive trend. As one goes up, so too does the other. But in this case, again, horsepower goes up, miles per gallon goes down, so we got a negative. Now the other thing is the strength. It tells you how strong the line is. So you have to interpret this as an absolute value. Oh, by the way, R is always going to be between 1 or including 1, less than or equal to 1, but also greater than or equal to negative 1. It's contained within these two parameters, between negative 1 and 1, including the endpoints. So anyways, this is the sign. Now the strength comes from interpreting just the magnitude, or we call the absolute value of the correlation coefficient, right? The stronger, or the closer this is to 1, the closer to 1, the stronger the line. So, anything over 0.75 we can say is relatively strong. You certainly wouldn't call it like super strong. This is pretty close to 0.9 though, so I would say this is a strong line. Surely anything above 0.9 can be considered a strong relationship. And of course, perfect lines will just outright have a correlation coefficient of 1 or -1. So again, it's the absolute value that determines the strength. It has nothing to do with the sign. The sign only tells you whether it's a positive or negative relationship. So that's that. And then D just says, well, what does this say? What does the plot say about fuel economy? Well, we've already been talking about this whole negative relationship, right? As one goes up, the others go down. So we saw that as horsepower goes up, miles per gallon goes down. So that's what we're looking for. Vehicles in the selected group with more horsepower have lower mileage. Perfect, right? The higher the horsepower, the lower the gas mileage. So hopefully that helps. Part C, you would just say you would say there's no evidence if the correlation coefficient was not strong. Like if you got like 0.6 or something, that would not be a very strong line. So you would just say there's not really enough information to say there's actually a linear relationship. But this is strong enough to say there is evidence, or at least some evidence to suggest. So again, B is the answer. Hopefully that helps, and take care. Thank you. Bye.